Hey, this is James Decon. Last video we worked on a height map terrain. We got it rendering in our project, but we had some limitations with that, so we could only render it with one texture across the entire terrain, which isn't really ideal. So today we're going to look at creating a custom terrain shader, and this is what we're going to end up with at the end, what we're seeing here. Now, there's a couple different ways to texture a terrain. One way is to use what's called a splat map, and I'll just show you what that looks like real quick and an example of one here. So a splat map is kind of similar to our height map that we're using. It's an image file that's encoded. You just have these different color values, right? And so when you would read the splat map image in your code, you could translate that so each of these color channels could represent a different texture or blending of the textures. And that's how a splat map would work. Now, a splat map is nice because you can paint pathing and you can create custom paths all throughout your terrain. Today, what we're going to look at instead is something a little, it depends on your needs. I kind of prefer the technique we're using today, which is going to auto texture the terrain based on the slope of the terrain and then based on the height of the terrain as well, which you can see we're doing here in this video. We can see that on the steeper slopes, there's a different texture. And then after a certain height value, the texture starts blending, the flat terrain starts blending into a different texture as well. Now, there's a couple things I want to cover. One is, so why are we going to use a custom terrain shader? And that's because the default in the PBR shaders they're more general purpose model shaders. They don't have any built-in support for doing this kind of blending of the terrain for the textures. If you know a way to do it with the default with the PBR shaders, I'd love to hear it. There are some downsides to doing it this way, doing a custom shader, and I'll get into those later. But the main thing that you want to know is that for when you create a custom terrain shader, you're not going to have all the features that are built into the default or the PBR shaders unless you implement them yourselves. So when you have your own shader, you're controlling it, right? So anything you need, lighting, shadows, if you want normal maps, all of that you're going to have to add in yourself. Now the great thing is we can look at the PBR shaders or the default shaders and get an idea of how they did it, and usually we can reuse a lot of that same code and bring it over, but that's it's an additional challenge. Now, are there other alternatives to creating a custom shader? Well, it could be possible to extend the PBR shaders and add in these features to it. Then you can get all the benefits of the PBR shader. However, the PBR shader is pretty complex, and doing that, trying to implement these features in that shader would be more involved. So I'm not going to be doing that because this is a tutorial and I'm trying to keep things as clear and concise and just focus on the terrain side of things. But this tutorial should give you an idea of how you could add the features to the PBR shader. I just want to keep it simple. Now, if you're not familiar with shaders in libGDX as well, then you can consider this to be a crash course. I won't be covering every single detail of shaders, but based on what I cover here, it'll give you a good idea. And then I always recommend look at the default shader in libGDX, look at the PBR shader, and look at even the particle shader to see how to extend the other shaders, just to get an idea of how they work in libGDX. So I got some great feedback from the last terrain video and a couple corrections here as well. So I mentioned the limitations for the vertices and the indices on the mesh size, and that's partially due to libGDX using a short type instead of an integer type. And I guess that's due to some hardware just not supporting integer indices. And so it's more of a hardware limitation. But you can still have up to 64,000 vertices, so that's good to know. Now also one code correction as well that MGSX pointed out is that for the texture filter, actually it does not support mipmap for the mag filter, which if we come over here and hit Control P, we can see we have min filter, mag filter, and to fix that, we can just change this to linear instead for the mag filter, and that should be it for corrections. So I guess not too bad. So okay, so we'll go ahead and get on with the terrain shader now. So before we start creating the terrain shader, I'm going to make a couple quick changes because I noticed some micro stuttering when I was in windowed mode, but not in desktop mode. And I think this has to do with the backend, the LWJGL3. So I've updated to LWJGL3 on the project. And so that's also some changes here. We had to change the desktop launcher class a little bit to comply with LWJGL3. And that seemed to clear up most of the micro stuttering that I was seeing when I was in windowed mode. The next thing I want to do is implement a new mode for the camera, fly mode, which allows us to detach from the slime and fly around so we can easily look at the terrain without being stuck attached to the slime. Okay, so with those changes, I should be able to launch the game and press the tab key to unlock the camera and just fly around. And you use Q and E to move up and down, and your middle mouse to actually turn the camera. And this WASD to move around. And that's good, because we're going to want that for later. So the next step is we want to try and replicate what we have here, but with our custom terrain shader. That'll be our baseline, is to render this terrain as it is in a custom shader instead. So we'll get started by creating, you'll want to create a new package here for shaders. I already created it. And inside of that package, a new Java class, we'll call it the terrain shader. And so I've already done most of this code in advance, and I'll probably be copying and pasting over from that just because I don't want to type everything out again. But I'll try to, of course I'll still try to walk through it as best as possible. So for this terrain shader, we're going to extend base shader, which is what most of the shaders, like default shader, extends from as well. So I'll just implement these methods. And then we're going to create a constructor here, and we'll take in a few parameters. So I'll create the constructor, and we'll want our renderable. Okay. Add the insert key on. And then we also want the default shaders config, and you'll see why shortly. And if you're wondering where I get, where I'm figuring this stuff out from, I mean, I'm still learning. This is my first time creating an Uber shader, which is what we're doing today. And so I've been looking a lot at the default shader, the PBR shaders, trying to understand how they do it. And I've just pulled pieces over that I need. So it is helpful to look at, for example, the default shader. I can split this to the right. And while I'm working on my shader, it helps to look at what they're doing. Grab over, we're doing only a terrain, so we don't need everything that's on here. We just want to take over the pieces that we need. For instance, we're going to need this renderable here. And so we have to set that on this constructor. There we go. And we're going to want to create a prefix. We might not need it yet, though. Let's go ahead and do this. So we're going to have a string prefix, and this is why we need the config. So we'll call the default shader. Actually has a static method for creating a prefix, and we'll see what the prefix is here in a minute. When we're debugging it, we can take a look at that. Another thing we're going to want is this. We can see this attributes mask. That's going to come in handy later as well. All right. So of course we gotta set this. And if you're wondering, I'm bringing over code from somewhat from here and somewhat from my own project, because it's going to be a little cleaner than what we have in the default shader. But we're going to set the attributes mask to this combine attributes mask method, which actually exists in the default shader, but it's a private static. So I'm just going to pull this straight over because I don't think we need to make any changes to this. We just need this same logic on our end. So we'll just put this down here. And this creates a mask inside of this long, which helps us identify, and we'll see that later in our can render method. So now we're going to need to have our own texture, right? We're gonna have a base texture. We'll have a height texture and probably a slope texture. But a couple things we need just for a basic shader to get rendering as well. So let me just get my bearings here. We want to compile the shader as well, so we can make that our next line. It's going to change a little bit, and I'm going to bring in another method just to get the default shader and the vertex shader. I'll show you what this is. They're just returning some files that we're going to create. So GDX files, internal. We're going to create these files here in a minute. These are going to be our actual shader code, the GLSL, and so we'll put this here for now, and then we'll create them momentarily. But this line is actually instantiating and compiling the shader based on the string that we pass in, which is going to come from this these methods here. And then we're also going to prefix the shader code with this prefix string that's going to be created here. And the idea behind the prefix string, let me just talk about that a little bit now, is it's going to process this renderable, and it's going to determine what the renderable needs. It actually creates these different flags, and it's kind of, think of a string where you're just appending all these different lines to it that define certain flags. And then in our shader code, this is how we make the shader code dynamic, is when we write the shader, we can check, is this flag defined? Is there a directional light flag defined? If so, compile with the directional light code. If not, well, then don't include that code in the shader. It's just a waste. So that's the general idea behind what's going on here. But we're going to reuse the create prefix from the default shader, because we actually need some of these prefixes we're not going to need. Some of them we do want, and we're going to reuse it as much as we can. Okay, let's finish filling out some of these overridden methods here. So for the init method, I'm going to look at what we have in the default shader. And we do need these lines here. And we shouldn't need the rest of these lines. We'll be handling this differently later. What do we have next? We have compare to, so we can pull that over as well. I think, yeah, there's even a fix me in here from the libGDX source, but that's fine. If it's worked for them this far along, I guess it works. So can render. Yep, so let's take a look. Yeah, so what I'm going to do is actually going to be a little bit different from the one in the default shader. I think they're checking bones and things like that. We don't have bones in our terrain shader. So it's actually going to be a little bit simpler. So remember this combine attribute masks. We're going to get the attribute mask for this renderable that's asking if this instance of the shader can run it or not, or can render it or not. So we'll get that, and we're going to compare that to this shader's attribute mask. So this instance, right, that gets called on this method. And if it's true, if the masks are the same, then sure, this shader can render it. If they're different, then that means we need to look for another shader or compile a new one that can render this renderable. Next up, we're going to need to pass some uniforms to our shaders when we create them. And so uniforms are values, or they're variables, so put it this way, that you can pass information you can pass from your terrain shader or from your shader to the GLSL code, because we need to pass information. And there's a couple of different ways that it's done. But generally, if you're passing information from your code, it's going to be through a uniform. And we need to grab a couple of them from the default shader, some basic standard uniforms that you use that you need to render a model and position it correctly. So the ones we're going to need, let's see, we want this projection view trans, and the way these are set up in the default shader is you have this static class inputs, and you have another one called setters. And so you can register these uniforms, right? So you register the ones that you need, and you register the setters that you need. And when you have done that in your own shader, the rendering of the shader, it'll be handled for you. It's going to call the setters that you need, and it's going to set those uniforms for you. And it makes it a little bit easier so you don't have to manually write a bunch of code to set all these setters. So that being the case, we're going to grab a few of these, the ones that we need. And we don't actually have to grab this code here because we can just use what's in the shader. So what we will need is, see if we can find it here. Take a look. Here we go. So we'll need this guy. And I'm just going to copy what I have. I want to show you where it's coming from, but I'm just going to bring over what we have or what we need. And we'll just put it up. We'll put them up here. So these integers are going to represent the registered uniforms when we register them. You'll see that in a moment. So if we go back to the default shader, we can look at how that's happening. So we can see right here, it's calling this register method and passing in the input and setter. So the ones that we need, right, those three, I'll pull those over. And that's going to happen in our constructor. We're going to register these. And we can do it after the terrain instantiation, just like this. So next, we need a way to pass information about our terrain to our shader. And to do that, normally in libGDX, we use what's called material and attributes. And if we take a look at the height mapped terrain right now, we were already doing that. We were using this PBR texture attribute, which comes from GDX GLTF. And we could take a look at that and see that this extends something called the texture attribute. And if you take a look at that, this extends this base attribute class. Now, if we take a look at the material class in libGDX, just bringing it up here. Okay, so if we take a look at that, we can see that material extends attributes. And I'm going to come over here. Now, so normally this is what we would do, right? So we would create our own custom attributes, and this is mentioned in the libGDX wiki. It talks about creating your own attributes and extending the attribute class, which is something PBR or GDX GLTF has done, which is great. But we're going to be using a similar system, but we're going to be creating our own terrain attribute and terrain attributes in a terrain material. The reason why is because there is a limit, and I had recorded this video originally following the same pattern here, creating custom attributes this way, and I actually ran into, so there's a hard limit of how many attributes you can register, and so this uses a bit mask long, which is limited to 64 bits. And the problem with that is, that means you can only register 64 of these custom aliases here. So, right now, I think, depending on what you're doing in your project, you may only have 20, 25 registered. But, it's just not scalable. And so if you're using custom attributes and you're using other libraries that also use custom attributes, you might, and now you want to add all these different terrain attributes because, a terrain can have a lot of different attributes being passed in. You might hit that 64 limit really quick, and we want to avoid that. So I don't want to show you, an approach that's not going to scale, especially if we want to improve on this and add lots of different things to the terrain down the road. So instead, what we're going to do is we're going to create our own version of these for the terrain only, so that the terrain will be able to have its own, up to 64 of its own attributes, completely separate. So what I'm going to do, I'm going to copy these classes here, attribute and attributes, and in our terrain package, I'm going to create a new directory or a new package, and I'm just going to call it attributes. And let's paste these in. And I'm going to press Shift F6. I'm going to rename these to terrain attribute. And so for attributes as well, just call it terrain attributes. Okay, let's take a look at these. It should have refactored. I think it will refactor. Yeah, so it refactored all the references to attribute to terrain attribute, so that's great. Let's make sure there's no errors here. So this has been refactored to be a terrain attribute instead of just an attribute. Perfect. Okay, so that looks good. The next thing we need to do is create our custom terrain material. And we'll also have to create some attributes for that as well, some terrain attributes. So the first thing I'll do is, let's get that material going. So what I'm going to do is check out the libGDX material class. And similar to the attributes, I'm going to copy this class. Because it just makes it easier for us to reuse all that existing logic. And I'll put this terrain material in the terrain package. And then Shift F6 so we can rename it. So here we're going to have to change the attributes to use the terrain attribute that we created. So this was attributes, and then attribute. Okay, I think that got all of them. Yeah. And I'm just going to clean up these imports here. Okay, so now we have our terrain material. Well, we need to create some attributes to put into our terrain material, like texture data. And if we want to pass anything else like floats, we would create a attribute for that as well. So let's start with our texture attributes here. And we'll start by, a lot of this we're just able to reuse or borrow from libGDX. Since we're using their same kind of system, just recreating it for materials. So we need our own terrain texture attribute. And, we could start by grabbing this attribute class, texture attribute, and pasting it here. And rename that to terrain texture attribute. All right. All these aliases and everything is going to have to change though, and we're not going to want any of these helper methods. We don't need them. Go and get rid of this one. Okay, but we do want the texture description. We want these offset and scale UVs and UV index. We'll keep those. Okay, so now we're going to bring over our own, we're going to use our own custom, we're going to register our own custom aliases for terrain textures. And so let's take this information out here. And I'm going to just copy over what I have to save a little bit of time. So we have diffuse base. So we're going to just start, for rendering purposes, we'll just start with the base texture. But let's just add all these in now while we're here. And then we're going to have a diffuse height alias will register. And then also a diffuse slope. So these would be 3 textures. One for our base, one for our height, one for our slope. And we can update this mask here as well. Okay. So that looks okay. We'll be able to use, so we can use this now to assign. So what we'll be doing is setting this attribute on our custom terrain material, and then we can get that terrain material later on in the shader and retrieve the textures that we need. Because the textures, of course, are stored in this texture description here. So now what we're going to do is head over to our height map class so we can actually do what I just described there. Before we were using this PBR texture attribute, and now we're going to change this to use our new custom texture attribute. So let's try it. Let's say terrain texture attribute equals, and we can just go, let's see, how do we want to do this here? Okay, you know what? Yeah, I actually have the code for it too, so I'll bring it over. If you saw, I removed a bunch of these convenience methods when we copied this over. And I'm going to bring over convenience methods for these new ones. So all it does is a static method, create diffuse base, diffuse slope, height. Makes it a little bit easier to create an attribute. So you just pass in the texture, and then, it's just passing in the long value that you need already. And so then we can just call that here, terrain texture attribute, create diffuse base. All we need is the texture, which we have that code here. And let's remove this texture attribute. Okay. And actually, can undo that. We actually want to keep the scales. And we can just rename those, move them down here, below. And we can just, also let's rename this while we're here. Let's call this the base attribute. And then paste that. So now we still have that scale being set. Okay, now so we have this material, and we're still going to have to use a material. But let's create our terrain material here. Now, terrain material set base attribute. Okay, what do we got here? Terrain texture attribute. Oh, you know what I missed? Yep. So we have to update this. So we copied this texture attribute, but we have to update this to use the terrain attribute instead of extending attribute. Let's see. So yeah, we have to update that compare to method. Let's take a look at that real quick. So it's still using attribute instead of terrain attribute. There we go. What else do we have? Down here as well. Replace that. Okay, good. So where were we? Height map terrain. Now that error is gone away, we can set this on our terrain material. And we still need a way though, because when you access in the shader, when you access the materials, or when you access the renderable, you have access to a few things. You can access the material on it, the environment on the renderable, and there is a custom user object you can set. For now, I mean, that could be another way to do it. So we are still going to use the material to pass this, and it's a little weird, a little confusing. But what we'll be doing is we'll be setting the material as its own attribute. So the terrain material is going to be carried along by the material, and maybe it'll make more sense when we implement it here. And that means we're going to need one more class. So we are going to create one custom attribute that will work with the regular libGDX material. So that means we only have to register one new custom attribute rather than registering a dozen or so for a new terrain. And I think I've already created that, so I'm just going to bring it over. It's pretty boilerplate. Let me paste it in here, and I'm just going to call it a terrain material attribute. Now this terrain material attribute, and let's see what we have. Got some errors when I brought it over. I'll take a look at that. Clean up these imports. I think, yeah, probably just a bad import there. So I should be able to remove this now. There we go. Okay, so this terrain material attribute. Now you'll notice that these custom terrain attributes we've created, they are extending or implementing. So they're using the terrain attribute, and our terrain texture attribute is extending from our terrain attribute. I know it's a little confusing here, but this terrain material attribute is going to continue to extend from the libGDX attribute. This is going to be the one custom attribute that we're going to add to the libGDX attributes. And all it's going to do is hold our terrain material. So we'll have so this is, like I said, this is pretty boilerplate. It's all the usual things that you have to create for when you're making a terrain, your own custom attribute. So I've got a convenience method here that just takes in a terrain material and returns this terrain material attribute. Like I said, this is just kind of a way to pass our custom terrain material to the shaders. And so if we come back here, let's see. We will need to... Okay, yeah, so we'll have to set on this material. We'll go terrain material attribute, create that attribute, pass in our terrain material. There we go. So hopefully this makes sense. Let me just real quick walk over what we're doing here. We're creating one of our custom attributes for our terrain. I'll call it a terrain attribute, which is going to hold our texture data. We're passing in this diffuse, our base texture. We create the terrain material and we set that terrain attribute on it. Now we create a libGDX, a regular libGDX material, which is what we're going to use to send this data over to our shader. On that material, we create this material attribute and pass in our terrain material. So basically our material is going to hold our terrain material, right? That's the workaround that I've come up with to get around that 64 limit to avoid, basically to make the terrain scalable so we don't have to worry about running into that 64 limit. So I hope that's not too confusing. Now we need a way to tell libGDX to use our custom shader. And libGDX uses something called shader providers. So let's go to our main class here, where our loop is at. And let's take a look when we instantiate the scene manager from GDX GLTF, right here. Let's step in here. So scene manager, has a lot of different constructors, so you can customize it to your needs. But you'll see that scene manager is using this shader provider. It creates a default PBR shader provider here. And that's, we're going to have to, so what we're going to need to do is extend this class and have some logic that can tell libGDX. If it's terrain, then use our custom terrain shader instead. Otherwise, continue using the PBR shader provider. To do that, we'll just create a custom shader provider. So if we go down to our shaders package in Java class, let's just call it custom shader provider, because this could be used if you add other custom shaders down the road. You could use the same shader provider. All right. And so what we'll want to do is override the create shader method, the one that takes in, let's see, I think we just need the one that takes in a renderable. And so right now, yeah, so this is where we're going to do that kind of redirecting to determine, this is kind of like the control center to tell libGDX, hey, what shader should I use to render this renderable? So what we can do is we can access the renderables material and check if it has that custom terrain material attribute that holds all of our terrain data, or that holds our terrain material. All right, so if our renderable has that material, that custom terrain material, we're going to call a new method, create terrain shader, and we'll pass in the renderable, and it's going to return. So let's put return create terrain shader, And let's create that. So I just hit Alt Enter, then I can create that method. And now here we'll call shader equals new terrain shader. And we can pass in our renderable. And what we need, that config as well. That's fine. Okay. Can call, let's just do a logging statement here. I'm going to do this because it's going to demonstrate some things later. Public tag final. Just creating a quick tag here. Class. What did I miss? Custom shader provider. Oh, you know, I forgot the string here. Okay. So dot class dot what do we got? Get simple name. There we go. So pass in that tag, and then let's add a statement here. Terrain shader compiled. And this just every time a terrain shader gets compiled, we'll be able to see it in the logs. And then finally, let's return that shader. Okay, I think so. That's all we should need for our custom shader provider. Now we have to actually set it for in our scene manager. So yeah, we'll go over to here to where we're instantiating the scene manager, and instead, you know, we got a lot of different constructors we can use here. You can see that we can pass our own shader provider, so we'll do that. New custom shader provider. And then for the depth shader provider, we'll just create default depth, and I think it just uses 24 by default. You know, this I'll just put in 24 as well for that. You can change this for your needs as needed. And I think let's take a look here. Yeah, let's create a public constructor. Okay. Let's see, this custom shader provider. That no argument constructor. And we'll call the super create default config, which will get that config created for us. And so yeah, let's get rid of this guy. So it's just going to create the configuration for us. We don't have to worry about passing it in. All right. And then depending on your project, you know, you might have to make some modifications to this. But this will work for what we need. So now if we try to run the application, if we try to run the game, it should now attempt to render our terrain with the terrain shader provider, but I'm expecting an error because we haven't actually created the GLSL shaders yet. And there we go. So perfect. So this means that, hey, it tried to find the terrain GLSL shaders and it couldn't find them. This means, though, that the redirection is working from the custom shader provider. It tried to create a terrain shader. It didn't work. So that just means we got to create our actual shaders now. Let's create the GLSL files now. And I'm just going to put them in the assets, new directory, shaders, and we'll create. In fact, I'm just going to bring them over and then I'll walk through them with you, as I've already created them here. So we're going to have our vertex shader, and our fragment shader. So we'll look at the vertex shader first. And I've kept them, these are pretty simple for now because we're just trying to replicate what we had before, which was rendering just a single texture. So we have some attributes coming in which are handled for us, they're passed in for us. These are vertex attributes coming in. We have the world transform, projection view transform, which is the camera combined value if you take a look at the camera class. And then we have this diffuse UV transform, and this is going to represent our scale, offset, and scale UVs. And we haven't actually set those up yet, but we're going to do that soon. And then this is going to represent, the result of this will represent the actual texture coordinates. that we're going to use when we're reading the texture. And we're creating a world position, and that's just by taking the world transform times the vertex position, and then we assign that to GL position. So this right now is relatively, it's pretty standard. There's nothing. Vertex shaders are usually the simpler part of the process. If you go to the fragment shader, I do have a line up here. Now this project that I've created, I don't have it set up for anything but desktop. I didn't do Android or anything like that. So these shaders I haven't tested on Android. Sometimes there's little nuances with the hardware or the operating system. Sometimes they don't like, if you put sometimes they require to put a 1.0 instead of just a 1 for a float. Little things like that. So there may be little nuances like that come up if you try to run this on Android, but they should, usually they're pretty easy fixes. But I put this in here. This is just for, I think it's just for Android, where you have to specify the precision of the float values. And so for now, we're just setting it to high precision. And then, so we have two things. We have this varying vector 2, V diffuse UV, and if you notice, it has the same name as this here. And so this varying indicates that we're sending it from the vertex, and that's why we put this V underscore in front of it, as this is being sent from the vertex shader to the fragment shader. So we calculate it here, and then we send it to our fragment shader. Whereas the transform, we only need it in the vertex, so this is a uniform, and then you can see we do U underscore. And this is just a common way of naming the variables in the shader, and I got this from looking at libGDX shaders and PBR as well. Okay, so we've got that. So this is getting passed in from a vertex shader, and this is going to get passed in from our terrain shader in the Java side. We haven't set that up yet, so we'll be doing that part next. And this is going to be our base texture, and it's uniform and then sampler 2D. So to get the color out of this texture, we call this function called texture2D. We pass in the base texture in the texture coordinates. That gives us a vector 4 RGBA, so that's our color values. And then we just assign that to this GL frag color here. So as I mentioned, so this is our basic shaders first, and so now we've created them. But we still need to pass in this diffuse base texture. And we also need to pass in this diffuse UV transform. So let's take a look at our terrain shader. And to do that, we're going to follow a similar pattern from the default shaders. And I'll just show you where I'm getting this from. They have these static classes. We have one called the inputs. And I think I might have talked about this already, the setters. Yeah, I think I showed this earlier because we're already using some of these in our terrain shader. We're registering these default shader inputs. So yeah, I think I already talked about these, but now we need to create some custom versions of these for our terrain information to pass to our shader. And so we can do that just by following the same pattern here. So I'll create these at the top, and we'll just do public static class. And we'll just call it, let's call it terrain inputs. And so we're going to register the new uniforms that we're going to need. So one is the base texture, and then 2 is going to be that diffuse uniform. So this is registering those uniforms so that we can send this data to our shader. And then we're going to have the setter class as well. Terrain setters. And I'm going to just copy over what I have for the base texture here. And then we'll take a look at it. So I'm going to have this custom get terrain material method because we're going to be calling it a lot later. And it's just going to, and I'm actually going to move it out of that static class and put it down here. And this class is going to do this. Okay, so yeah, it's just going to take the renderable material and get our custom terrain material attribute from it. and then return the terrain material, which is held by that terrain material attribute. It's a tongue twister. All right, so we come back up here, and so yeah, we get the terrain material from that renderable, and now we get the diffuse base, because this is going to be our base texture setter. Diffuse base texture. We'll retrieve that attribute, and then we're going to bind that attribute texture description, and then set that unit value. And so this is going to set it and send it to the allow it to be set and sent to the shader. And what we'll do now is, so we got to register them just like we did with these other values here. So let's see, save myself some typing here and just copy them over. So we have the, these will be, we'll call these material uniforms. So we've got the base texture, and we need that transform for the UVs. And now let's register them. Okay, yeah, oops. Well, we got to create the setter for the UV transform as well. Let me grab that. Here we go. Put it at the top. Okay, so yeah, we'll take a quick look at this one then. So again, we get that terrain material, and now we're going to use the base textures scaling values. We're going to use the base textures UV values for all the other textures. If you want to expand upon this later, you're welcome to. I know for me, all the textures I'm using are the same size. So usually the scale value, it's okay for me to use the same scale value, but you may want to change this. But for now, so yes, we're going to get this base texture, and we're going to use the offset UV, scale UV, and set those. So that's going to be our diffuse UV transform. And so when we register that, we've registered the input for it, the uniform input, and the setter. And now I'll grab the, so yeah, we need the base texture. We need to register that one still. There we go. Base texture, and we got the input and the setter for that. Okay. And we're going to need one more piece before we try to run this. And I think after that, I think we'll be able to run it. I'm going to override the begin method inside our terrain shader, because the way that, this is from my understanding with OpenGL, the general recommendation or the general approach is to, so you get this render context here. And, you know, depending on what the shader is trying to render, it may need different values set for depth testing. Do you want it enabled or not? For coal facing, or for face culling. And also, there's this depth mask that you can enable or disable depending on what you're trying to achieve. And so the general approach is when you start your shader, when you're starting to render that with that shader, you modify the context to have the values that you need. And so for this, for terrain, we're going to use a depth mask here. So we're going to use GL less is the, or not depth mask. I'm skipping ahead. We want the depth test in our, it's going to be our depth function. And for now, I'm going to use GL less and just keep the default 0 and 1F for the near and far range. Okay, because we are going to have depth testing on our terrain, of course. I'm also going to cull the back faces, because so that what that means is, you know, the back face of the terrain. So underneath it, if you look at the terrain from underneath and you look up at the terrain, if you don't cull the back face, then you'll see the textures on both sides, from the bottom and top of the terrain. And that's just unnecessary for what we need. We don't need to see the bottom of the terrain, so why render that? So just to save a little bit of rendering here, we're going to only render the front face and not the back face. And now we're going to set the depth mask to true. There's another adjustment that we'll have to make before we try to run this code, and that's going to be in our height map terrain. I noticed, and I'm not sure if this is just a nuance or what exactly is going on here, but if I noticed if I make changes to a material, I set a custom attribute on there, and then after that I pass that material into our model builder, either the attributes are getting casted back down to a parent attribute or they're just getting removed, which is really odd. To get around that, because as I'm not sure what's going on there, I'm going to move the model building code up here and instead create a new material and pass that into the model builder. And then I've got a line, I'm just going to grab this over. So we'll now grab the material from the model instance that was built by the model builder. It's kind of a workaround, I'm not sure what's going on there. But instead, so I create a new material, pass it into the model builder, then retrieve that material from the model instance. We know it's going to be at index 0 because we're only adding one material. And let's just change this line here. And actually, we don't need that line at all. And then at the end, we'll set on that material we retrieved, we'll set the terrain material attribute on it. So let's try running it now. And there we go. So now we are rendering the terrain with our custom shader instead of GDX or the PBR shaders from GDX GLTF. And you'll notice, probably notice pretty quickly that there's no lighting. And so it's really hard to tell, it's really hard to see the accents of the terrain, but we can see it's there. We're going to have to add some basic lighting later just so that, just to fix that a little bit. And again, this was something I mentioned early on. When you create your own shaders, you don't have that lighting code anymore. You're going to have to implement it yourself in your custom shader. But this is good progress. We're now rendering with our custom shader. And if you wanted to kind of test, like if you're not sure if it's working or not, if your terrain shader is being used, a quick way to test that, you could go to your fragment shader, your custom fragment shader, and set the GL frag color to a vec4 and just assign it all to 0. And then I know for me, when I change a shader, I actually have to recompile it. And then if I run this now, the terrain should just be all black because we set the colors to 0. And it is. So, that just confirms that our custom terrain shader is being used to render this. And so let me undo that change here. There we go. So next up, we're going to change out our texture and add some new textures as well. And, when I was making this video, I was looking at that sand dunes texture a lot, and I just wasn't feeling it. So I really like the look of stylized textures, and they look good, especially on lower poly models. And since our terrain resolution is kind of low, I think these just look a little better. And so what I did is I went ahead over to CG Trader and I just searched up for PBR stylized, and I looked for some free ones that are royalty free on them and found some from Lowly Poly that I really liked. The 3 that I'll be using is this one here and this one. So this is going to be our low terrain. This one will be our higher terrain, and this will be our slope texture, like a kind of like a cliff face. And so these are the 3 that I'm going to have. Now, if you want to download them here, you can, or they'll be in my GitHub repository as well for this video. So you can pull them from there if you want. And so now I'm just going to go ahead and copy those into our project. And I think I forgot to add these to the last video, to the repository. So let me make sure I click add here so that I'll actually push these to the new branch. All right. And so now we have to actually call these or use these textures. So let's come back to our height map terrain, because that's where we're assigning these to our terrain material. And I'm going to create a kind of convenience method here, because there's a lot of code we can reuse, and call it get map texture, and we'll pass in a path, the path to the texture. And then I think we can take most of this code. I'm just going to copy it first. Move it down here. Then take that path string to replace this call here for the file internal. And okay, yeah, so that should be it. And then we just return the texture. We come back up here where so now we can remove, like, well, before we move it, let's copy this string. Actually, you know what? We don't even need to copy that because that's our old texture. So let's just remove those lines. And so instead we'll pass in the get bitmap texture method. And for the string, textures, and I think so the one we want for our base is number 19, volume 19 here. That's the one that's going to be our base texture. Oh, not that one. We want 19. Was it 19_2? Or no, _4. 19_4 is a base color. You can, a quick way to copy it is if you hit Shift F6 over here. It'll bring you up to the rename dialog. You can copy it that way too. Paste it in. There we go. Okay, let's test this out real quick. Let's see if that texture is getting pulled in. And it is. Very cool. So now we have that base texture set. And now what we're going to do is create the other two attributes. And to do that, I will just copy over the code, save us a little time. So we're going to have a slope texture and a height texture. And make sure if you're doing this, that you're calling those different methods. So we call diffuse base, create diffuse slope, and create diffuse height, and pass in the right textures. And all we have to do is we have to set these on our terrain material. Like that. There we go. Now we need to go over to our terrain shader and set up the inputs and setters for our two new textures, the slope and the height. And so let me bring over what I have already, because it's all going to be the same, very similar to what we already have. And let me move the transform up here. So we've got our base texture, height, and slope uniforms. So nothing too crazy here, just some more uniforms to pass into our shader. And we'll also want the setters for slope and height. And so the only real change is really just here, so you could probably even make this reusable, most of this code. But you see diffuse base, diffuse height setter, and diffuse slope setter. And so we have to register these, so we'll need to create some integers here. And then, yeah, so now we register them. And again, make sure you're calling the right input and setter, height, slope, and slope. Okay, yeah, so next up what we're going to do is, now that we have these new textures ready to be passed into our shader, we are going to start with the height blending. So we're going to add that now to our shader. So we're going to finally have more than one texture. So let's head over to our fragment shader, because that's where we're going to make these changes at. And here, so we're going to need another sampler 2D to sample the height texture. And if we look at our terrain shader, we are assigning this uniform to a diffuse height texture. So we'll paste that here. And now I'm going to bring over a method, a helper method, because we're going to use this for blending. And the idea here is to take a value and so take a range, should I say, and normalize the value between 0 and 1 based on the min and max range. And they'll still make sense to you in a minute. And I think I just found this online. This seems to be a common approach to doing this. So we're going to use this for our blending as well. And the idea, what we want in the output is a value between 0 and 1, because that's how we are going to, when we blend, we're going to pass in that value to an interpolation function, and that's going to be the interpolation amount based on what this returns. To do our actual height blending, we're going to need some information from the vertex shader. So let's head over to there, and I'm going to create a new varying float and call it v world height, because we're going to, so to do our height blending, we want to know at what height is the current fragment that we're processing in the shader. And to set that, we have this world pause value. So underneath that, we can just set v world height equal to world pause dot y. And now, so then we'll, oops, we don't need the float there. We already defined it up here. So we can just say world height equals world pause dot y. And let's copy that, head over to our fragment shader. And so this is going to be, part of our height stuff. I'll put that here, this varying float v world height. And so now we're going to use that in a moment. So for our height blending, let's set up a couple float values here. We'll have a min height, and that'll be equal, so we'll just set it to 5.0 for now. And that's where they're going to be the world height where blending begins. So that's going to be where we start blending to the height, to the height texture. And then we'll have a max height, and that'll be the world height where blending is 1.0. So at that point will be fully blended to the height texture at that height in the world. Let's create this blend value and call our normalize range function, passing in the world height as the value, and then min height, max height. And now we can go diffuse. And I mentioned an interpolation function earlier. That's what we're going to use now. So we're going to interpolate between the base texture color and sample the, so we're going to call texture 2D, sample our diffuse height texture, use the same diffuse, or use the same texture coordinates as the base, and we pass in the blend as our interpolation value. So the first value, this first color, should I say, second color, and then the blend value determines how much the output's going to be. It's going to determine how much to interpolate. If it's 0.5, then you're going to have kind of a half and half. And so, for example, with these values, if the world height was at 10, then the value would be 0.5, right? So it's going to be in between 5 and 10, so the interpolation would be 0.5 in that case. All right, so yeah, we mix that and assign that to diffuse, and then we pass that diffuse to the frag color. And I'm going to just rebuild that because I need to recompile both of the shaders. Let's try to run this. All right. And so we can see here that it's working. If we look, we see the base texture, and then we see blending into the height texture. And if we take a zoom in, you can kind of see it's like a basic kind of interpolation blending here, where the two textures, where it changes from one texture to the other. And we'll be able to see this more as we go along. As we implement slope, it'll be even more noticeable, that blending. Right now, they know that these two textures are kind of the same color, but you can even see right here, you can see more drastically that change between textures based on the height. So this is good. This is working. All right. Now I'm going to change a couple values on the terrain, just so that the heights are a little more pronounced. So let's change this size of the terrain to 400. And I want to change the magnitude, which I think that's in our main class here. Wherever we create our terrain. Let's see. Oh, right here. So we're having a magnitude of 30. I want to make that 60. All right. And yeah, so even more noticeable now. We see this lower terrain has the low texture, and then the rest of the terrain is using a mixture or just full on using the height texture. Next up, we're going to try to implement the height, not the height blending, but the slope blending. So we'll have like a rock texture when the slope is a certain degree. And so I think we're already setting we're already setting that value, or we're already setting that texture, should I say. We have this diffuse slope that we've set. So if we go into our terrain, again, similar to how with height blending we needed a world height, well, we're going to need some additional information to do the slope blending as well, and that'll come from our vertex shader. So if I bring this over, let's see what we're going to need. We're going to need a new attribute. Should be a normal. So again, as I've mentioned before, these attributes are usually they're taken care of for us. They're passed in, and we know our terrain is created with normals in the vertices, so we're covered there. So we can get this a normal value, and then we're going to need two more things. We're going to have this normal matrix and v normal. That'll be what we're going to calculate and send. That'll be our surface normal. So we're going to calculate that and send it over to our fragment shader. And if we take a look at the, let's see, terrain shader, did we register that already? We did. We registered the normal matrix already, so that's taken care of for us. So that's going to get passed in. And then the v normal, if we come down, I'll add a new section here just to calculate that. So we're going to take the normal matrix times the vertex normal, and that's going to give us this v normal, converting it to a camera view space, and then we're going to pass that in to our fragment shader. And so what we'll need to do is, actually, let me copy that varying normal there, so that we have it over here. And I'm just gonna an extra space here because we're actually gonna separate these a little bit more later. But for now, let's just do this. So we got the slope be the normal, and to implement the slope blending, let's do height blending comment, and then slope blending. Okay. So to do that, we can go, we're going to create some new floats, just like we did with the height blending. Minimum slope, 0.85f, and I'm using some values that I found look nice, but you can change these. 0.99. Oop, I know I'm putting F in there and I shouldn't, so no, don't put the F for float. And so the way these are going to work is the higher that the min slope is, the more slope texture will be visible. And the lower this max slope is, equals less slope texture visible. And now we're going to create this our interpolation factor. We'll call it slope weight, and call our normalize range. And we're going to pass in that normal, the v normal y value, min slope, and max slope. I just realized that should be a capital H there on max height, so let's fix that. Okay, and just like we did before, we'll call diffuse mix, and this time I'm going to pass in the texture 2D sample first of the slope texture, which I think we still need to, we still need to add the uniform for that slope texture, so let's do that now. Go to our terrain shader, get the uniform name, copy that. Here we are. So let's now sample that. That'll be the first value we pass into the mix function. And so our second function will be diffuse. And then, okay, so we got texture 2D. Oh, yeah, I'm getting a little mixed up here. So inside our texture 2D, we need to pass in the texture coordinates. So there we go. Then a comma for the mix function. Now we pass in diffuse. So the current color of the textures, and then pass in our slope weight for our interpolation. Okay, so yeah, that should do it. That should apply some slope here. And let's recompile both of these. And I'll try to run it. All right. Here we are. And so it looks like, yeah, it looks like we're working. We can see we got our base texture. And now we can see on the slopes that there is when we start blending to the sloping texture when the angle gets to a certain threshold. And then we're just full on that slope texture, and then we blend back out of it when the terrain flattens out a bit. And then, of course, we got the height texture at the top. And so you can, of course, play with those slope values to find what you like, what looks good to you. This is just, again, this is just to get things started. But this is good. What we're going to do next is look at turning this into more of a dynamic, kind of an Uber shader, as it's called, which will recompile the shader on the fly as needed. So it's going to recompile the shader and only include in the shader code what is needed. So we're not doing any unnecessary calls, and we won't have any like if conditionals in a shader, which we usually call it branching, which try to avoid as much as possible. And instead, we'll be doing an Uber shader next, so we'll see that in action. To convert the shader to an Uber shader, head over to the terrain shader class, and let's head to the constructor. And so we're going to need the terrain material. And when you construct a new shader, the render bowl gets passed in, and then we look at that render bowl to determine how to build the shader around that render bowl, only give it what it needs. So we'll start by getting the terrain's material. Okay, and then first we're going to create another mask here. So we'll go private final long, and we'll call it the terrain mask. Or let's call it the terrain material mask, just to be specific here. And we'll assign that after we do our attributes masks. And we'll just call terrain material.get mask, because we've that's all built into how we've extended attribute and attributes. We already have this method available to us. If we go down to our can render method, right now we're only checking if on the combined attributes, which is environment and material. Now this isn't enough because we're using one attribute that holds our terrain material, right? But if we change something within that terrain material, this isn't going to, the mask isn't going to change for that material. So we can first do this check. So let's change this to be an if the attribute mask is not equal. Yeah, so if the renderable that's being passed in for this can render method to determine if the shader can render it or not. First, we'll just say if the combined mask is not equal, then we'll return false. Now, if it is equal, which would mean that this renderable also has a terrain material attribute on it, well, now we need to compare the terrain materials to each other. The one that's on this shader and the one that's on the renderable getting passed into this can render method. And to do that, we can, let's see, okay, yeah, so we'll return terrain material mask equal to get the terrain material of this instance that was passed in, get mask. So we're going to get the terrain material mask from the instance that's passed in here and compare it to the terrain material mask that we assigned when this shader was first created. If they're the same, then we know this same shader can render that other renderable. If they are different, then that's going to trigger the compilation of a new terrain shader that can render this renderable instead. Now the next step is to create some additional prefixes in our prefix string that we have here. Right now we're calling create prefix from the default shader, but we're also going to add more prefixes on top of that. And I'm just going to copy what I have. We'll talk through it here. Let's do it down below these. Okay, so we're getting our terrain texture attribute from the terrain material. And so for this one, we're getting the slope. And if the attribute's not equal to null, so if the terrain material has a slope texture, then we're adding a new part, or we're adding a new string to this prefix appending. And we just go define. And then we pass in the alias, which is this right here. And then we just add flag to the end of that string. And I'm doing the exact same thing here, but we're doing it for diffuse height. So we're going to create a flag, a define flag for slope alias and height. And that'll make a little more sense in a moment when we get to the shader. But just to show you what those look like, I'm going to drop a debug point right here, and we'll just take a quick look at the prefixes. Okay, and if we go down here to the prefix, we can click view. So now we can view that string that's going to get passed in. So this is going to get appended to the top of the shader code. So you won't see this in your GLSL file, but it will be there when it's compiled. And we can see that in our case, we have a slope and a height texture on this terrain. And so both of those defines are there. And now we can use these flags in our GLSO code to determine what logic is needed in the shader and what logic is not needed, which will make the shader as lean as possible. Now we can head over to our terrain frag shader, and let's try to implement these flags now. So we can wrap, let's start with our height, and I'm just going to copy. So we have we have here, we'll go if defined, and so that's our diffuse height texture flag. So if it's defined, then we will declare these variables here, and then we can call end if. So now these variables are only going to appear in the compiled code if that flag is set. And so now let's come down and wrap the height blending down here in the same flag. And if. And I'm just going to indent these. It's a little easier to look at it. And now let's do the same thing for slope. So I'm going to head back here. And the alias is diffuse slope texture. And so let's head to here and wrap this up now. And so we're actually going to need the normal later. I just know this because I think we'll be using it for lighting. So I'm not going to wrap the normal. And I'm just going to move that normal up to this area that where we're saying, you know, hey, we always expect these values to come in regardless. The shader, we always expect these ones to be there. All right, let me copy that flag for the slope texture. And let's wrap the slope logic in that flag. There we go. Okay, so now I'll show you how this works at runtime. So this looks good. We have our variables wrapped, so we only wrap what we need for height inside of this flag, and we've got the logic, slope, and height wrapped as well. So I'm going to let's recompile. Let's actually just rebuild, and I'm going to start this up in debug mode. If you remember in the previous terrain video, we set it up to where we could press F1 to to recreate the terrain. And so we're going to use that now. Let me just make sure. I believe we did that. Yeah. So if F1 is pressed, create the terrain, and that disposes of the existing terrain and then creates another one. So let's go to our console now. And we can see that line printed out, terrain shader compiled. Now first, if I press F1 right now, it's going to recreate the terrain. You won't really see anything visually, but it did recreate it. And you'll notice in the log below that it's no new statement. It didn't say that I compiled the shader again because it doesn't need to recompile it. There's already a shader cached. So when a new shader is compiled for an Uber shader, it caches it. Since we already have a shader that's that can work with this terrain, it didn't need to create a new one. However, if we now go into our height map terrain class, let's remove the sloping. So let's remove the slope texture from the terrain material and rebuild. So Control Shift F9, and that should reload my classes. And then I'm going to press F1 and watch the logs below. There we go. So now you can see that the log file down here, it compiled a new shader. And that's because in the can render method right here, the terrain material mask was different because one of them, the first shader that we compiled, had the slope texture as part of the mask. But the when we recreated the terrain, that terrain renderable came through here, and it had a different masking because it did not have a slope texture on the material, and that triggered a new terrain shader to be compiled. So now the shader being used here doesn't have any of the logic in it for texturing the slopes. So you know that if you didn't want slope textures, that now you can clean up your shader. You don't want to have that extra code in there if you don't need it. So hopefully that makes sense. Then lastly, if we undo that change, so we bring the slope texture back, reload, and then bring this back up. I'm going to press F1 to recreate the terrain again. Pressed it there, and then scroll down here. Another shader was not compiled. It's using the first one that we compiled initially. So it's using that cached shader. And that's one of the advantages of the Uber shader is, let's say I had, 20 of these terrains and maybe only one or two of them had a slope texture on them. Well, now you're going to have a custom shader for those different terrains that only have the logic in it that's needed, rather than making additional calls or going through additional logic or having to have conditionals in your shader. You don't need any of that when you do it this way. So right now, I think we're good on the texturing. Things are looking good. So the next step will likely be, I think we're going to look at adding some basic lighting to the terrain now. That's what we should do next. So that's what we'll do. Before we start on lighting, I realized I missed one other piece here. In our vertex shader, we also have access to the prefix. So we should not forget about that. And I think in our vertex, right, we're calculating that world position height. So we could also wrap that here, since we know we only need that if we have a height texture. And let's just recompile that and start it up. And yeah, so everything looks good. Everything's still working. And now we have one less instruction that we have to send in the shader code that if we don't need it. To implement lighting, we're going to have to make some more changes in our terrain shader and our shader code as well. And what I'm about to show you here, I've kind of pieced this together from looking at the default shaders and looking at the PBR shaders as well, just to kind of get us going. I'm going to be moving kind of quick here because this isn't a lighting tutorial, but I don't want to leave you without any lighting on your terrain either. So try to follow along here. And what I'm first going to do is add another line to our prefix. And this is going to check if the environment has the ambient light color attribute on it, which is what we are using in the on Scene Manager. When you set ambient light, and we step in here, you can see that Scene Manager is setting the ambient light value. It's setting it on this color attribute.ambient light. So we're going to, in our terrain shader, we're going to check for that. And if so, we're going to add another define value here and call it ambient light flag. Next up, we're going to have, so we're going to only do one directional light. That's just to keep things simple. If you want to add more, then you can look at the default shader to see how they do it, because default, or the lighting uses a directional lights use an array in the, or not an array per se, but yes, it uses an array of structs. And let's just take a look at it while I'm talking about it. It'll maybe make a little bit more sense. Okay, is that in a vertex possibly? Let's see. And then you'll see also where this code's coming from. So we have this struct defined directional light in the default libGDX shader with a color and a direction, and then you have this array of directional lights here. Now we're only gonna, as I said, we're only gonna use one for now. But if you look at the default shaders and you want to add more, that's where you would figure out how to do it, is looking at how the default shaders have done it. But just to get our one directional light working, we're going to need a couple things. So we're going to need some more int values up here. And I'm getting these, if you're curious where these are coming from, again, it's coming from the default shader. I'll just put this under lights and dir light 0 color. Let's see, scope. Now if we go to the default shader, we can see what that looks like there. It's calling that U-directional lights array, 0 index color. You can see that, you know, to add the directional lights, it's a little, multiple directional lights, a little more involved, and that's why I'm just keeping it simple. Okay, and now we have to register these as well. We're actually going to register them in a different spot than everything else. These need to be registered up after in the init method before we initialize the program. And so that's what that looks like. Again, just copied from the default shader. And then for ambient light, go down a line here, and I'll bring that over. And the ambient light piece actually came from PBR shader. So it looks like, yeah, we're going to need an integer for this as well. Here we go. So fetch uniform location is going to get that uniform and assign, and we're going to get the integer value for that uniform. Okay, now we need to, in our render method, which we haven't overridden yet, so we need to do that. Override the render method that has the attributes in it. And before we call super.render, we're going to create a function called bind lights and pass in those attributes. And I'm going to bring over what we need here. Okay, combined attributes. Here we go. And so what we're doing is from the combined attributes, we are retrieving the directional lights attribute. And that will end up in it's an array of them actually. So now we can get that from this directional lights attribute.lights. And we'll say if it's not null, then we'll go ahead and set the those uniform values, the color and direction of the 0 index to the color values and the position. And then after that, we'll do our ambient lighting. And that's just getting the color attribute for the ambient light, making sure it's not null, and then setting that ambient light uniform value to the colors. And just to speak on this for a moment, you know, PBR is using a very, it's using a different lighting model than what I'll be using here. I'm going to be using like a Lambert's Law lighting model. And so the ambient lighting is not going to be a direct match to the PBR shaders. And I don't know how we can convert between those, between the Lambert and the PBR shader. I'm not sure if there is a direct conversion or not. So I just want to bring that up now. You might see some differences between how the ambient lighting is on your model versus your terrain. If you knew a better way to a conversion between those, that would be awesome. Leave it in the comments. Maybe down the line in a more in-depth tutorial, we could look at adding this terrain code to the PBR shader and then able to use the same lighting from the PBR shader. That would be ideal. That would be a lot more complex though. So for now, just be aware of that. There may be some differences between the conversion. It's not going to be 100% correct. All right, I think from our Java side, I think this might cover it. So we can head into the to our shader code. We'll head to the frag shader, and I'm just going to bring in the code we need. I'll talk through it. And like I said, you can either, if you want to pause it, you can pause it, or this code will be in my repository for you to take a look at as well. But let's just quickly walk through what's going on here. And I'm just formatting it real quick. So, okay, here we go. So if we have this lighting flag defined, which if I head back to the terrain shader, that should be getting defined from this method here, calling the create prefix from the default shader. That actually includes that flag. We'll just triple check, but that should be, or should already be in there, and we'll just make sure. All right, let's take a look at it. In our prefix, we have a few things. We have this number of directional lights, which is used to create the array, that dir lights array. Number of point lights. We won't be doing pointer spotlights right now, but this is coming from the prefix method. But that's what we wanted to check. We wanted to check if that lighting flag was there, and it is. So that's good. We know we're going to have that flag in our shader code. So we wrap all this logic in that flag, and then we got this diffuse light vector 3. And if that num directional lights, which we just saw, is greater than 0, then for the diffuse light color, we're now going to assign that to the color of the first directional light. And then we're going to take the dot product and normalize it of the direction and the normal. So this is going to give us the angle of light between the normal and the light direction. And the closer the dot product is to 1, so the closer that this is to 1, that means the less the angle is between those two vectors, which will result in a higher, so we're going to have a higher value here, which means it's going to be times by this, right? And so that will allow that will cause the color to be brighter. So the more in line the two angles are between the direction and the normal, the brighter the diffuse light color will be. And so that makes sense, right? If the light's hitting it from a really drastic angle, then it's going to be darker. Now we also have that ambient light flag here. If we have the ambient light flag set, then we're going to have another, we have that uniform. I think we're going to have to add it still to the shader, ambient lighting. And we're just going to plus equal that to the light. And then in the end, we're going to apply this diffuse light to our output color. So we're going to take that red, green, blue, the RGB, times equals our output of this diffuse light here. And that's what we'll then end up with, passing that to our GL frag color. So let's go to the top. I think we need to add these up here as well. Let me bring that over. So again, everything's wrapped in this lighting flag. If the number of directional lights is greater than 0, we create this struct, or we define this struct here, and then we create this array of the number of directional lights so that we can pass in the directional light array to the shader. Alrighty. I think this might be everything we need to get just our basic lighting working. I don't think I missed anything, but we're going to find out. So let's rebuild. Okay, well, it definitely looks a little different. We have slight signs of some lighting now going on here. And I think what I'm going to do is let's reduce the ambient lighting. It'll make it a little, just so it's a little more visible. It'll make it a little bit darker in the dark areas. And now if we take a look, so we can see that you can see the terrain is shaded darker on this side of it. That's that ambient light applying. And if we set this really low, you know, we should be able to see it even more. Okay, there we go. So now we can really see that ambient lighting. Because the ambient lighting is so low, the terrain is going to be much darker in the shaded areas. And the higher that ambient lighting is, the lighter the dark areas will become. Now the lighting is kind of, you know, it's not very detailed just because the resolution of the terrain is pretty low. And the higher the resolution of the terrain is, the more vertices, the better the light will end up looking as well. But yeah, that gets us some basic lighting on our terrain. I think we've accomplished the main goal that we wanted to accomplish, which was creating that custom terrain shader and rendering it with some basic lighting. And now what I'm going to look at, if you want to stick around, I just want to show you how to change these hard-coded values that we have in the shader, because we hard-coded the heights and the slope values here. And what if you wanted to change these? Maybe you have certain terrain pieces or certain terrain chunks that you want to have a different slope value for, or you want the height to kick in at a different point. And to do that, you could make these values configurable to where you can pass them in via your code and even change them on the fly, which is pretty cool. So that's what we're going to look at. We're just going to do that here, and that'll be the last thing that I'm going to show. And we're just going to, like I said, we're just going to do it with one value. And then if you want to convert the rest of them to a uniform, that's something you can configure from the code. You can do that and follow along. The process will be exactly the same for each one. So to get started, we're going to need another custom terrain attribute. So right now we only have the terrain texture attribute, but now we're going to need a float attribute because that is what those values are. And if we look at the float attribute from GDX, we're just going to copy this as we've done before. Let's copy that float attribute and bring it up here. And then I'm going to rename it Shift F6 to terrain float attribute. There we go. And so I think this had shininess and alpha test. Well, we don't need those here. So we can remove that. We can remove this one. In fact, we'll just keep it and rename it because I'm only adding one for now. So let's just change these to let's do the slope. We'll do the minimum slope. And then once we do this, we'll be able to change it on the fly and watch the slope texture kind of change. It's kind of neat to do it at runtime. So I'm just changing the alias to min slope. And min slope alias. And don't forget, actually, we have to change this. This no longer will extend attribute, it'll extend terrain attribute. And so yeah, we're gonna have to fix a couple things in the code because of that. So here, copy should return a terrain attribute. And here, compare to should take in a terrain attribute. All right. And so we already have, right? So the float value for the attribute gets stored here because we copied it from float attribute. It's already taken care of. It makes it a lot easier. And we'll just put a create min slope function, a convenience function. And let's put in min slope there. All right. And then I'm going to just clean up these imports, Control-Alt-O. And that should be it for our attribute. Let's head over to our height mapped terrain and set that attribute. And so we can do that. Let's try it. So we called it the terrain float attribute. Slope equals terrain float attribute and call that static method. And let's set it to, well, let's just set it to the default for now, which is what's in the shader, 0.85. And then we have to apply that down here to the material. There it is. That's all we should need here. And so back to our terrain shader now. We're going to need to create, register a uniform for this. And yeah, so we're going to register a new uniform for the min slope. And that's going to look like this here. So first we come to our inputs, register the uniform, u_min slope. And then we need a setter for that. And here we go. So our min slope setter, get the material, get the min slope from attribute, terrain float attribute, and then set that value. And now we need another integer here. And then we register it. Min slope, register it to that min slope input and setter. All right, so now we just take that uniform. I think we're all wired up. So copy that min slope. And let's head to the frag shader. And we'll have a uniform, and we'll wrap it in the slope texture flag. So we'll say uniform float min slope. Copy that. And we will replace it. We'll replace that min slope here with the new uniform. And I'm just going to make sure that this builds and runs. And yep, so it looks good. Okay, and now let's do one last thing here, which to change this in runtime, which will look, looks pretty cool. We'll just do a couple, we'll poll for some inputs and then make some changes based on that. So we can say if GDX input is key, we'll say is key just pressed, and we'll go with F2. Then if it's pressed, let's get that terrain float attribute. From the terrain, now we might have to make a change here. We could do it this way. It's a little messy, but this is just test code anyways. We know we only have the one material on the terrain, so let's get that material. And I'm going to clean this up a little bit just so it's easier to see what's going on. We'll say material mat equals this. Then let's get the terrain material equals mat.get terrain material attribute dot terrain material, and we'll have to cast that, I think. Nope. Let's see. Okay, this extends attribute material.get. What is it complaining about here? Oh, oops. Yeah, so I'm trying to assign it to terrain material. That's not going to work. So we have to actually do a cast here to the terrain material attribute and wrap this in that cast. Now we can get that terrain material. And let me move this code back up. So it's a little, I know it's a lot. Unfortunately, you have to do this workaround with the attributes. But now we can scale the terrain. So we have terrain float attribute equals. Okay, so yeah, now we got to get that from the terrain material. Get terrain float attribute dot min slope. All right, now we have, so this is going to give us access to the min slope attribute. And so we can just modify it now. So we'll say if F2 is pressed, we will add 0.01 to the min slope. And now I'm just going to copy this. And again, this is just test code. If F3 is pressed, we will decrement it, or minus equals 0.1. Actually, yeah, I think we want this to be is key pressed, not just pressed. We want it to be is key pressed. Otherwise, we'd have to press the key 100 times to really see much of a difference. And I'm also going to add a limit to this, math.min, and we'll pass in the current value and then 0.9f. I don't want the value to get beyond the max slope. Otherwise, it'll just cause an issue. It'll cause a rendering issue. It will look weird. So that because that min slope should stay below the max slope value. So we're going to take the minimum of these two and use that. And now if I start up the game, and I'll just hit those keys. So as you can see, I'm tapping F2, F3. We can see that as we increase or decrease that min slope texture, or the min slope float attribute, we can see how that affects the terrain. And this is great if you to create these uniforms, set up these custom uniforms in your shader, make it more dynamic, and allow you to change these things at runtime. And even just if you're not sure, like, oh, what value do I like? What value looks good? You could set these uniforms up and either debug or print them out, and then just test this at runtime rather than make a change in your shader, recompile the shader, restart the game. You could just make these configurable and set up a hotkey and change them and find what looks good to you. So it's pretty fun to play with. And I would recommend, depending on what you want, you might want to set up uniforms for these values just so you can change them per terrain chunk. So that's it for this tutorial. This is my first time creating an Uber shader, and so I've been learning as I go. If you noticed any mistakes or improvements, I'm all ears. Send me some comments. And but I hope this was helpful. I know I haven't seen a lot of videos out there or really content in general on how to create a default shader, or not how to create, but how to create a custom shader in libGDX. Even more so, I haven't seen much on how to create a Uber shader, a custom Uber shader in libGDX. So hopefully this was helpful. Please like and subscribe, because that's what tells me that I should make more videos. If there's not a lot of interest, then I'm not really motivated to make more videos. So I definitely appreciate those who watch, and let me know if this was helpful.